icy compounds on the surface of this dwarf planet. But when we look at Pluto from space like so, you also see this hazy blue crescent. Pluto actually has an atmosphere, which is really strange because, again, it is so far away from the sun. There are planets closer to the sun that don't have much of an atmosphere to speak of, like Mars and Mercury don't really have too much of an atmosphere to speak of. But Pluto somehow has retained this very thin, tenuous atmosphere. It's the only dwarf planet that we currently know of to have an atmosphere, which, if you ask me, is pretty interesting. All the way out here, close, but not at the edge of our solar system. My friends, I've actually taken us past the time when I was supposed to let y'all out of here. So, I know we said we'd go to the Earth for the grand finale. Neptune. You want to fly by Neptune? We can do that. I can fly us to Neptune before we go. I was gonna say we could end the show by flying out to a supernova remnant. Would y'all like that?
Yes.
Okay.
Yes.
No.
Yes.
I figure we started the show with that picture of a stellar nursery, and I told you there are different types of nebulae. Okay, here's Neptune. Wait, flow to Neptune. Hi, Neptune! There has only been one spacecraft that has ever made the trip out to Neptune. That was Voyager 2. We are long overdue for a Neptune mission, if you ask me. So hopefully in the near future, we will have another spacecraft head out to this distant world. For now, we only have data from our telescopes as well as the data from the Voyager 2 mission to go through to learn about this world. But if we want to end with a supernova remnant, we better start flying out there now. So you can say goodbye to Neptune. Goodbye to our solar system. Bye, solar system. Goodbye to the Milky Way galaxy. Bye, Milky Way. We are headed further than we have gone in any trip during this show. We're going about 160,000 light years away, out in the direction of the Large Magellanic Cloud. It's a dwarf galaxy that orbits the Milky Way. And now that we're out of our galaxy, we can see some of the larger galaxies, the brighter galaxies that surround us in our vast universe. So our sun, one of about 200 billion stars, our galaxy, one of trillions of distant galaxies we've observed out there. Our destination, right front and center, is our supernova remnant. So does anyone know what a supernova is? Anyone have a guess?
No.
A supernova is when a giant star explodes. So our sun is not a giant star. Our sun will not explode. What our sun will do is just as interesting, if you ask me, and it's not going to happen anytime soon. Our sun has about 5 billion years left to shine. But stars that are way bigger than our sun, stars that are 20 to 700 times more massive than our sun, explode in these massive supernovae. By the way, here's our Milky Way galaxy. I mentioned at the start of the show I'd show you where we are in the Milky Way. Here's the center of our galaxy, so that's where we find Sagittarius A star. We are right about here, okay, in the Orion arm of the Milky Way. Little detour there. Back to our supernova. This is showing us, again, the end of a massive, massive star. So supernovae are some of the most powerful explosions in our universe. So after a massive star has run out of fuel, it can begin to collapse under its own weight. That can cause the star to explode, sending out strong shock waves from the interior. So that's your average supernova. The one we're looking at right now is actually a rarer subtype. It's known as a supernova type 1A. And I do have a little animation to show us how we think this supernova might have gone down. Let's go ahead and pull it up. We'll be looking down at a cloud of gas and dust, but as we get closer, you'll see not one, but two stars involved. These two are what we call white dwarf stars. They are small, hot, dense core remnants left over, sometimes from sun-sized stars, locked together in a gravitational dance of doom, fated to spiral in closer and closer and closer and closer and closer and closer and closer until, wait for it, they collide in a massive supernova explosion. When these stars explode, they create heavier elements. things that we find here on earth, shiny things, sure, like gold and platinum, but also things we find within ourselves, like the iron in our blood and the calcium in our bones, forged in the death of a massive, massive star. I find it quite poetic. When these stars explode, they send out those strong shockwaves, again carrying within them those heavy elements, the ingredients for life as we know it. These shockwaves tear throughout the universe where they might hit another cloud of gas and dust. Then, as it hits that cloud, things start to spin around and around and around and around. As more stuff gets added, more mass to that cloud, it eventually ignites. And that, my friends, is how our sun was born. Our sun is known as a third-generation star. The ingredients for our entire solar system could not exist if there had not been 2 generations of giant stars to come for it. So if you ever hear we are all made of the stuff of stars, that is the cosmic journey that is referring to. The journey of every atom in our body. It has indeed been quite a cosmic adventure. So when you go outside tonight, when you look up at that sea of stars, I do want you all to think about that journey. But I also hope that you think about some of the great questions of humanity. Where did we come from? Why are we? Where are we going? And are we alone? I don't know if we'll ever have all the answers to all of those questions, but something I do know, just because I know humans, we are very curious, I know we are going to keep on looking for answers. And